In late May of 2026, a thermometer in Moura, Portugal registered 40.3 degrees Celsius, a number so far outside the normal range for that time of year that meteorologists initially checked their equipment for errors. It was not an error. Within days, France recorded its hottest national average temperature ever measured in the month of May. The United Kingdom broke its all-time record for the warmest May day on record, and at least 11 people across Western Europe were dead. A month later, England posted its hottest June on record, with the country as a whole coming in as the second warmest June ever measured for England and Wales combined. Weeks after that, on the first days of July, Ontario and Quebec sweltered under humidex values north of 46 degrees Celsius, triggering thunderstorms so violent they knocked out power to more than 100,000 homes. This is not a story about a single bad summer. This is the data trail of a planet whose baseline temperature has shifted. And the people who study this for a living are telling us, in plain language, that we have not yet reached the worst of it. That is the uncomfortable center of this story. Not that the heat is bad right now, although it is. The real warning, coming from National Weather Services, university researchers, and some of the most experienced climate scientists alive today, is that the heat the world experienced in 2023, 2024, and 2025 was not a peak. It was a preview. And depending on which of several converging forces plays out over the next few years, what comes next could make the last 3 summers look mild by comparison. Let's start with where things actually stand using the numbers rather than the headlines. The last 11 years in a row have been the 11 hottest years ever recorded in modern instrumental history. Not 11 of the hottest, the 11 hottest back-to-back, with no exceptions. Scientists at Berkeley Earth have pointed out that the pattern in the last 3 years does not fit the slow, steady warming trend the planet followed for the previous 5 decades. Instead, there has been a kind of acceleration, a bend upward in the curve that researchers did not expect to see this soon. Part of that acceleration has identifiable causes. New international shipping regulations cut the amount of sulfur pollution vessels are allowed to emit, and while that pollution was harmful to breathe, it also had an accidental side effect of reflecting some sunlight back into space and slightly cooling the planet. Removing it took away a kind of unintentional shade. At the same time, the sun itself has been going through a period of peak activity in its roughly 11-year cycle, adding a small but real boost of additional energy reaching Earth. Neither of those factors is the main driver. The overwhelming majority of the extra heat, researchers are clear, comes from decades of accumulated greenhouse gas emissions. But the sulfur reduction in the solar cycle, stacked on top of that existing warming, and the combination is part of why 2023 through 2025 jumped so far past what long-term trend lines alone would have predicted. Here is where the forward-looking warning becomes specific rather than vague. The United Kingdom's Met Office, whose forecasting models are used by governments and insurers around the world, released a projection stating that 2026 is likely to land between 1.34 and 1.58 degrees Celsius above the pre-industrial average, with a central estimate of about 1.46 degrees. If that estimate holds, 2026 will be the 4th consecutive year the planet has spent above the 1.4 degree mark. The scientist who led that forecast said this pace shows how quickly the world is closing in on the 1.5 degree threshold set out in the Paris Agreement, a limit that was once treated as a distant guardrail decades away, and is now something we can see approaching in real time, year by year, like a shoreline coming into view. That 1.5 degree number matters more than it might sound. It was never meant to be a magic line where everything suddenly becomes catastrophic on one side and safe on the other. It was chosen because the scientific evidence available at the time suggested that beyond that point, the risks of extreme weather, ecosystem collapse, food insecurity, and mass displacement all rise sharply and start to compound each other in ways that are much harder to manage. Crossing it for a single year is a warning shot. Crossing it consistently, year after year, is the difference between a fever and a fundamentally changed baseline temperature for the human body. Climate monitoring groups, including Copernicus and Berkeley Earth, have separately calculated that if current trends continue, the planet's long-term average is likely to breach that 1.5 degree mark permanently by around 2029. That is not 100 years from now. Depending on your age, it might be well within a working career, a mortgage term, or the childhood of a kid who is a toddler today. And here is the part that should really sit with you. The World Meteorological Organization has stated that an El Niño weather pattern is forecast to develop by the end of 2026. El Niño is a natural cyclical warming of parts of the Pacific Ocean that happens every few years, and it has historically been associated with the hottest years on human record because it adds an extra layer of heat release on top of whatever the background warming trend already is. The lead author of the WMO's Outlook stated plainly that this developing El Niño raises the odds that 2027 becomes the next record-breaking year for global temperatures. Read that again. We are still absorbing the consequences of the heat waves of 2025. We are living through an already dangerously hot 2026, and the forecasting agencies that governments rely on for disaster planning are already pointing toward 2027 as the next likely record holder. "The worst heat is still ahead" is not a dramatic tagline. It is closer to a literal transcription of what meteorologists are telling reporters on the record. James Hansen, the former NASA climate scientist whose 1988 congressional testimony is often credited with putting global warming on the political map in the United States, has been especially blunt. In an update posted on his website in the middle of 2026, Hansen argued that many of his fellow scientists are still underestimating how sensitive the Earth's climate system actually is to the greenhouse gases already in the atmosphere. His own projection is that 2026 will end up as the warmest year ever recorded, surpassing even 2024, despite the year starting out cooler than that previous record holder. Hansen has a track record here that is difficult to dismiss. In interviews, he has pointed out that scientists understood decades ago, based on physics that was well established even then, that continued fossil fuel pollution would drive temperatures higher along a fairly predictable path. What has surprised even veteran researchers is not that warming happened, but how closely reality has tracked and, in some cases, outpaced projections that were treated as worst-case scenarios when they were first published. While the air temperature numbers get most of the headlines, many of the scientists tracking this crisis say the more alarming data is sitting underneath the surface of the ocean, literally. Oceans absorb the overwhelming majority of the extra heat trapped by greenhouse gases, something like 90% of it historically. A study led by researchers at the Chinese Academy of Sciences, working with an international team of collaborators, found that the oceans absorbed an extraordinary quantity of additional heat in 2025. One of the climatologists involved in that research described the scale of that absorbed energy using a comparison to detonating hundreds of nuclear weapons worth of energy. A jarring image, but one meant to convey something scientists have struggled to communicate for years. The ocean is not a passive backdrop to climate change. It is functioning as an enormous reservoir that stores up heat and then releases it back into the atmosphere in ways that intensify storms, feed heat waves, and keep nighttime temperatures elevated long after the sun goes down. That last detail, warmer nights, deserves its own moment of attention because it is one of the more dangerous and least discussed aspects of the heat crisis. Historically, even during brutal daytime heat, the human body got some relief once the sun set. Nighttime cooling gave the body and the built environment a chance to shed accumulated heat before the next day's peak arrived. Warmer oceans reduce that overnight relief. When nights stay hot, the cumulative strain on the cardiovascular system compounds day after day, which is part of why extended heat waves are so much more lethal than a single scorching afternoon. Emergency room data collected during past heat waves consistently shows death rates climbing not on the first hot day, but several days into a sustained event, precisely because that nighttime recovery window has been squeezed shut. This brings us to a genuinely unsettling piece of new research that reframes how scientists think about what actually kills people during extreme heat. For years, the commonly cited danger threshold was something called the wet bulb temperature, a measurement that combines heat and humidity to estimate the point at which the human body can no longer cool itself by sweating, because the surrounding air is already too saturated with moisture to absorb any more. The widely used threshold for that limit was 35 degrees Celsius on the wet bulb scale, a level considered on paper to be the outer boundary of human survivability, even for a healthy person resting in the shade with unlimited water. A team of researchers, led by Professor Sarah Perkins Kirkpatrick at the Australian National University, working with colleagues at the University of Sydney, published a study in the journal Nature Communications that overturned that assumption. Using a new model grounded in actual human physiology, rather than a simplified theoretical threshold, the team analyzed 6 real-world heat waves: Mecca in Saudi Arabia in 2024, Bangkok in Thailand in 2024, Phoenix in the United States in 2023, Mount Asa in Australia in 2019. Larkana in Pakistan in 2015, and Seville in Spain back in 2003. What they found was that so-called non-survivable conditions, meaning conditions the human body physically cannot compensate for, regardless of hydration or rest, were reached in every single one of those 6 heat waves, and at temperature and humidity combinations well below the old 35-degree wet bulb benchmark. In other words, the real danger zone is both cooler and drier than the previous scientific consensus assumed. Every one of those 6 events, except the one in Australia, was associated with at least 1,000 deaths, and many of those fatalities were attributed at the time to cardiovascular or respiratory failure, rather than to heat directly, meaning the true death toll from extreme heat has likely been undercounted for years in official statistics. The lead researcher described her own reaction to the findings in blunt terms, saying she did not expect to see conditions that severe once her team zoomed in on individual cities. When the person running the study is surprised by her own results, that tells you something about how far ahead of public understanding the actual danger has moved. Layer that physiological finding on top of what happened on the ground in 2025, and the picture becomes even more sobering. Scientific researchers estimated that by mid-September of that year, roughly 16,500 deaths across Europe may have been directly attributable to the heat driven by climate change, a figure representing an estimated 68% of all heatwave deaths recorded that summer being linked specifically to the warming trend rather than to ordinary seasonal heat. Spain's National Weather Agency confirmed that the summer of 2025 was the hottest summer ever recorded in that country, with average temperatures between June and August coming in above 24 degrees Celsius, a number that sounds almost mild until you understand it represents an average across an entire 3-month span, day and night, urban and rural, mountain and coastline combined. North America has not been spared either. The 2024 heat waves across Mexico, the United States, and Central America stretched from March all the way through late September, an unusually long duration for what used to be thought of as a summer phenomenon confined to a few peak weeks. Death Valley, California recorded a peak temperature of 53.9 degrees Celsius, which converts to almost 129 degrees Fahrenheit during that stretch. Confirmed deaths across the United States from that event exceeded 1,000, with more than 1,000 additional deaths recorded in Mexico and thousands of heat-related injuries reported there as well. These are not estimates from advocacy groups or activist organizations. These are figures drawn from public health tracking systems, coroner's reports, and national meteorological agencies, whose entire professional reputation depends on getting the numbers right. Then came 2026, and rather than offering any kind of reprieve, the pattern simply continued, arguably with more intensity packed into a shorter window. The European heat wave that began in late May shattered records that had stood, in some cases, for decades, with temperatures running 10 to 15 degrees Celsius above what would be considered normal for that time of year. 10 to 15 degrees above normal is not a marginal deviation. That is the difference between a warm spring day and a temperature more typical of the peak of summer, arriving weeks or months early, giving ecosystems, agricultural systems, and human bodies no time to adjust. Climate researchers pointed directly to the warming trend as a contributing factor behind that shockingly early onset of summer conditions, not as one possible explanation among many, but as a documented driver consistent with decades of prior modeling. The United Kingdom's experience through the summer of 2026 illustrates just how compounding these events can become. After the record-breaking May heat wave, June brought a second wave, with the hottest June day record broken for 3 consecutive days in a row, eventually reaching a provisional temperature of 37.7 degrees Celsius. That heat combined with an unusually dry stretch to produce what meteorologists call a flash drought, a drought that develops far faster than the slow, multi-year droughts of historical memory, this one emerging despite the country having just come through a notably wet winter. Southern England ended up receiving only about 1% of its expected rainfall for the month of July, a number so far below normal that it triggered official drought declarations across 7 of the country's 14 operational water management regions, forcing early agricultural harvests, and prompting utility companies to introduce enhanced water monitoring and restrictions. And running alongside all of this were the human costs that rarely make it into temperature charts, including a string of drowning deaths as people, especially children, sought relief in lakes, rivers, and coastal waters, sometimes with tragic results, prompting official warnings from life-saving organizations about the dangers of unsupervised swimming during heat emergencies. The Southern Hemisphere, which experiences summer during the Northern Hemisphere's winter months, delivered its own warning in the opening weeks of 2026. A heat dome settled over Australia in January, pushing temperatures to nearly 50 degrees Celsius, which is close to 122 degrees Fahrenheit, in a country already well acquainted with extreme heat. At the same time, catastrophic wildfires tore through remote parts of Argentina's Patagonia region, killing 21 people in coastal towns in Chile, while South Africa simultaneously dealt with some of its worst wildfire seasons in years. 3 separate continents, 3 separate climate zones, all reporting record or near-record extremes within the same narrow window of weeks. Scientists monitoring these events describe them as consistent with a pattern where extreme heat is no longer an occasional anomaly confined to one region during one particular season, but a near-constant global condition that simply rotates its geographic focus depending on which hemisphere is tilted toward the sun. It's worth pausing here to address something that even experienced climate researchers have been saying out loud, sometimes with visible discomfort in interviews. The heat has started to genuinely surprise the people whose entire careers are built around studying it and predicting it. One prominent European climate researcher, speaking about the string of extreme heat events across Europe and the United States, said that record-breaking heat waves are stunning even the scientists who track the acceleration of climate change for a living. That same researcher has spent decades warning about risks associated with a system called the Atlantic Meridional Overturning Circulation, a massive ocean current system that helps regulate climate patterns across the entire North Atlantic region, including much of Europe's relatively mild weather compared to other regions at similar latitudes. He noted that when he first began raising concerns about the risk of that circulation system slowing down or collapsing, he considered a 5% probability of a serious disruption to already be uncomfortably high, given how catastrophic the consequences would be. His current assessment, based on updated modeling and observed data, is that the risk has climbed to somewhere around 50% or higher. That is not a small update. That is a researcher telling the public that a risk he once considered a long shot worth losing sleep over has, in his professional judgment, become roughly a coin flip. To put that in perspective, he drew a comparison to how society approaches risk in other high-stakes engineering contexts. When building a bridge or operating a nuclear power plant, the accepted standard is to design for something like a 1 in 10,000 chance of catastrophic failure, because the consequences of getting it wrong are so severe that even a very small probability is treated as unacceptable. Climate systems, he argued, deserve at least that same level of precautionary seriousness. And yet, society continues to treat climate risk with a kind of casualness that would never be tolerated in structural engineering or nuclear safety. So why does all of this matter beyond the immediate discomfort of a hot summer? Because the compounding effects reach into essentially every system modern life depends on. Rising global temperatures are directly linked, according to federal atmospheric researchers, to the intensity and duration of wildfire seasons, because hotter conditions dry out soil and vegetation more thoroughly, creating more fuel for fires to spread rapidly once ignited. Warmer oceans intensify not just heat waves, but also heavy rainfall events and stronger storms, because warmer air holds more moisture, and that moisture eventually has to come down somewhere, often in short, violent bursts, rather than gentle, absorbable rain. This is part of why the same regions experiencing record-breaking heat and drought are, in some cases, the very same regions later hit by catastrophic flash flooding within weeks, as happened in Ontario and Quebec, when extreme heat gave way almost immediately to thunderstorms so intense they dropped more than 4.5 inches of rain in Ottawa in a single event, and knocked out power to well over 100,000 homes. Public health systems, agricultural planning, electrical grids, water supply infrastructure, and emergency services are all built around historical patterns of weather that assumed a relatively stable climate baseline. When that baseline shifts as quickly as the data now suggests it is shifting, every one of those systems is operating with outdated assumptions. Hospitals plan staffing levels based on historical heat wave frequency. Power grids are engineered with cooling demand projections based on past decades. Reservoirs and water treatment systems are sized around expected rainfall patterns that no longer reliably hold. Insurance markets price risk based on historical loss data that increasingly fails to capture the frequency and severity of what is actually happening now. Every one of those systems takes years, sometimes decades, to meaningfully update, which means there is an unavoidable lag between the climate reality on the ground and the infrastructure meant to protect people from it. That lag is precisely where the most severe human costs tend to concentrate, in the gap between what is happening and what our systems are prepared to handle. There's also a psychological dimension to this that researchers have started to name explicitly. One climate scientist involved in the annual reporting on global temperature records offered a particularly striking framing, suggesting that in the coming decades, as extreme weather events grow more frequent and more costly, people will look back on the mid-2020s, the very years we are living through right now, with something like nostalgia as a comparatively mild climate period. Sit with that for a second. The years many of us are currently experiencing as unprecedented, as record-shattering as the hottest we have personally ever lived through are being described by the scientists, studying them as likely to be remembered in the not-too-distant future as the good old days, by comparison. That is not a comforting thought, but it is a useful one because it reframes the entire conversation. This is not a temporary spike we simply need to endure until things return to normal. The scientific consensus, delivered by multiple independent monitoring organizations working with different data sets and different methodologies, all pointing toward the same conclusion, is that this is the new floor. The floor is still dropping, or rather, the ceiling is still rising, and it has not finished rising yet. None of this is presented to induce despair for its own sake, and it's worth being honest about what the data does and does not tell us. It does not tell us that catastrophe is instant, or that every single year from here forward will simply be hotter than the last with no variation. Natural cycles, like El Niño and its cooler counterpart La Niña, will continue to cause year-to-year fluctuations layered on top of the underlying warming trend, meaning some years will genuinely feel like a step back, even as the multi-year and multi-decade trend continues climbing. What the data does tell us clearly and repeatedly from multiple independent sources that rarely agree on much of anything else is that the direction of travel is well established, the pace has recently accelerated beyond what long-term trend lines alone predicted, and the specific near-term milestone that scientists have used for years as a critical warning threshold, the 1.5 degree mark, is now being described not as a distant possibility, but as an approaching near certainty within this decade. Given all of that, what does the science actually suggest people should be doing differently right now in their own lives and communities? The public health guidance emerging from this research is more specific and more urgent than the general advice to drink water and stay in the shade that has circulated for years. Because the danger threshold for heat-related illness and death has been shown to sit lower than previously assumed, the practical implication is that people, especially older adults, young children, outdoor workers, and anyone with existing cardiovascular or respiratory conditions need to treat heat warnings with more seriousness at lower temperature and humidity combinations than official guidance may have suggested even a few years ago. Waiting until conditions feel unbearable before taking precautions is, according to this new physiological research, waiting too long, because the body's compensatory mechanisms can fail well before subjective discomfort reaches an extreme level. Communities and local governments are being urged by researchers to treat heat as the serious, named tracked hazard that hurricanes and floods have long been treated as, complete with early warning systems, cooling centers, and coordinated outreach to vulnerable populations, rather than as an unpleasant but background feature of summer. Some regions have already begun naming and categorizing heat waves the way hurricanes are named, precisely to raise public awareness that a specific heat event deserves the same level of preparation and caution as a named storm. Water safety organizations have specifically flagged the connection between extreme heat and drowning risk, noting that as more people seek relief in open water, often without adequate supervision or swimming ability, heat waves indirectly drive up water-related fatalities alongside heat-related ones. That is a pattern worth remembering the next time a heat warning is issued in your area, because the danger does not end with the temperature reading. It extends into every decision people make trying to cope with that temperature. At the level of the individual, the honest answer is that no amount of personal behavior change reverses a planetary trend driven by roughly a century and a half of accumulated greenhouse gas emissions. But personal preparedness genuinely does reduce individual risk during the specific extreme events that are now arriving with greater frequency. That means understanding the early warning signs of heat exhaustion and heat stroke in yourself and in people you care for, particularly the very young and the elderly, whose bodies regulate temperature less efficiently. It means checking on neighbors, especially those who live alone, during heat emergencies, because a significant share of heat-related deaths in past events occurred among isolated individuals who had no one checking on their well-being during the critical days of a heat wave. It means taking official heat warnings seriously, even when the temperature itself does not sound dramatic, given what the physiological research now shows about how much lower the true danger threshold actually is compared to older assumptions. And at a broader level, many of the researchers behind this data have been explicit that the underlying trend can still be slowed, even if it cannot be instantly reversed, through the kind of large-scale shifts in energy production and emissions that are already underway in various parts of the world, from expanding renewable energy capacity to changes in industrial and transportation emissions, even as those efforts currently remain outpaced by the accumulated warming already locked into the system. There's another layer to this that rarely gets discussed alongside the temperature charts, and that is the economic dimension of a warming baseline. Insurance companies, which are among the most data-driven institutions on the planet because their entire business model depends on accurately pricing future risk, have already begun pulling back from offering coverage in some of the regions most exposed to repeated extreme heat, wildfire, and flood events. When an industry built entirely around calculating probability starts quietly retreating from a market, that retreat itself functions as a kind of warning signal, arguably a more honest one than any political statement, because insurers have no ideological incentive to overstate risk. They only lose money by getting the numbers wrong. Agricultural economists have raised similar concerns, pointing out that repeated early season heat waves, like the one that hit Western Europe in May of 2026, can damage crops during flowering and early growth stages in ways that a late season heat wave of the same intensity would not, because the plants have not yet developed the resilience that comes later in their growing cycle. That means the timing of these events, not just their raw temperature, is becoming its own variable that farmers and food security planners have to account for in ways that historical planning calendars never anticipated. Energy grids face a related but distinct pressure. Air conditioning demand spikes sharply during extreme heat, precisely at the moments when extreme heat is also most likely to strain the power generation and transmission infrastructure itself, since many power plants and transmission lines lose some efficiency as ambient temperatures rise. That creates a dangerous feedback loop, where the exact conditions driving the highest electricity demand are the same conditions most likely to cause equipment failures or forced power reductions. sometimes resulting in blackouts precisely when air conditioning is most medically necessary for vulnerable populations. Grid operators in several regions have already had to issue conservation appeals during recent heat waves, asking residents to voluntarily reduce electricity use during peak afternoon hours, specifically to avoid rolling blackouts, a request that puts an uncomfortable amount of responsibility on individual households to manage what is fundamentally an infrastructure planning problem. It is also worth acknowledging how unevenly these risks are distributed across the global population, because the data on that point is just as consistent as the temperature records themselves. Outdoor workers, including agricultural laborers, construction crews, and delivery workers, face direct occupational exposure to extreme heat with far less ability to simply retreat indoors compared to office workers. Low-income households are statistically less likely to have reliable access to air conditioning. And even when they do, rising electricity costs during heat waves can force difficult choices between running cooling systems and covering other essential expenses. Elderly people living alone, as previous heatwave fatality data has shown repeatedly, face disproportionate risk not because of any single physiological factor, but because of the combination of reduced thirst sensation that comes naturally with aging, chronic health conditions that heat can aggravate, and social isolation that means dangerous symptoms can go unnoticed until it is too late. None of this is presented to suggest the crisis is unmanageable, but rather to underscore that the response to it cannot be a uniform, one-size-fits-all public message. The people facing the highest risk from the data described throughout this script are often the same people with the fewest resources to adapt to it, which is precisely why researchers keep emphasizing coordinated community-level preparation rather than leaving heat safety purely as a matter of individual responsibility. The through line across every single piece of this data, from the ocean heat content research out of China, to the physiological survivability study out of Australia, to the temperature forecasts out of the UK Met Office, to the on-the-record predictions from a scientist who was warning about this exact trajectory back in 1988, is remarkably consistent. Nobody studying this professionally, across dramatically different institutions, countries, and specialties, is describing 2025 or 2026 as the peak. They are describing them as data points on a rising curve, with the next likely record year already being forecast, with El Niño conditions expected to develop before this year is even finished, and with the psychologically striking suggestion that people will one day look back on this exact period, the one you were living through as you listen to this, as the relatively cool and stable years by comparison. That is the actual substance behind a headline that might otherwise sound like exaggeration for the sake of getting attention. The worst heat really does appear to still be ahead, according to the people whose job is to measure it, model it, and warn the rest of us before it arrives. The question this data leaves each of us with is not whether the warming will continue in the near term, because on that point, the scientific record from multiple independent sources is about as aligned as climate science ever gets. The real question is how seriously individuals, communities, and the institutions meant to protect all of us choose to take a warning that is no longer theoretical, no longer decades away, and no longer coming from a single alarmist voice, but from an increasingly unified chorus of researchers who, in many cases, sound less like they are making a prediction and more like they are simply describing something they can already see happening in the data in front of them.